Hey guys, just wanted to go over a few things with you. Hey, so yeah, we are doing this digital learning, and we do have a new unit that we're starting, and it's all about rational expressions. So I do have a Deltamath assignment that you can work through, and if as long as you can do these, you should be in good shape. But I wanted to go over a few of these problems with you from each one of these sections that I added to the assignment. So this is about half the unit. Okay, and it's all about simplifying rational expressions and then some operations that we can do with these rational expressions. So rational expression, okay, they look like this. Okay, they're just a fraction that's built out of equations. When we simplify, we have to factor. And that's the biggest skill that you're going to use in this section, factoring. You try to factor the top, you try to factor the bottom of each fraction, you find factors that match, and then you divide them out. Really, it's not too bad as long as you can factor. But I wanted to go over a few examples, one from each one of these sections, and just make sure you are okay with it. Okay, so here's our first one. And what we have to do is we have to factor the top, we have to factor the bottom of this fraction. So the top, x cubed plus 8x squared, there's a GCF. X squared divides out of both of those terms, and when you divide it from the first term, you're left with x. Divide x squared from the second term, you're left with plus 8. So now we go to the denominator, and we do the same thing. We just factor. Okay, so it's a trinomial, so we're going to use our product sum rules. It's going to break down into two groups. Okay, this part of each group is going to be x. And then the last term in each group will be two numbers that have to multiply to give us negative 8, but those two numbers also have to add up to a positive 7. So multiply for negative 8, add to positive 7, about negative 1 and positive 8. Those look like it. So we're going to put a minus 1 plus 8, and that will complete the factoring. Okay, now we look to see if there's any factors that match, where we have 1 in the top that matches exactly with one factor in the bottom, and those will divide out. So looking at the problem, we see the x plus 8 occurs in the top and the bottom. That's the piece that's going to divide out. Anything that's left is our answer. And our answer was, until I made it go away, x squared over x minus 1. Okay, so we'll try to enter that in, make sure that I did get it right. So let's go there. So we have x squared divide by x minus 1. And yeah. All right, good deal, good deal. So the Deltamath, it does walk you through the steps that you can use to solve it. You can see same steps, factoring, getting rid of the factors that match, and that's it. All right. So now we can use those same techniques in multiplying. So if you go to the multiplying and dividing, you look at some of the problems. They do look more complicated, but essentially it's the same thing. All you're doing is you're factoring each part of the fraction and then finding things that match and then dividing them out. All right, so let's take this example. Let's make sure we can do this. Let's see there. Okay, so start with the first fraction. X plus 9 is prime. You can't factor it. It's going to stay x plus 9. Okay, go to the bottom of that first fraction. You have x squared plus 12x plus 27. Okay, so yeah, that does factor. We're going to use our product sum rules. And I'm just going to squeeze the factored form in underneath. X and X. So now we have to find something that multiplies to give 27, but adds up to a positive 12. How about 3 and 9? Yeah, those look like it work. 3 times 9 is 27. Add up to 12. Okay, so now the second fraction. Okay, start with x squared minus 9. Let's see, how does that factor? It goes to x plus 3, x minus 3. Difference of two squares. And the denominator, we just have 8x cubed. Doesn't factor. Okay, it's just going to stay 8x cubed. Now, it's created from factors. 8 is 2 times 2 times 2. X cubed is x times x times x. So if you have any extra 2's or x's in the top, then those will cancel. Or you can use those to help reduce it. But let's just see what matches up as it sits right now. So we've got x plus 9, x plus 3, and x minus 3. Those are the three factors in the top. We have x plus 3, x plus 9, and 8x cubed. Those are the three factors in the bottom. Well, it's actually more than 3, but those are the factors in the bottom. So now any factors that match exactly, we're going to cancel them out, like that x plus 9, like this x plus 3. And it doesn't matter if the x plus 3 is in one fraction and the other is in another fraction. You just want to see one x plus 3 in the top and one x plus 3 in the bottom somewhere. Okay, and I think that's everything that matches up. Anything that's left is going to be part of our answer. So we have x minus 3 at the top. We have 8x cubed at the bottom. Okay, and that's all that reduces. Okay, you can't reduce, you can't divide out any x's because you don't have any factors of x in the top. All you have is an x minus 3. So nothing else divides out. All right, so let's see if this answer works. And we have x minus 3 over 8x cubed. Make that go away. Pull this up here. So we had x minus 3 over, well, we don't want that. We want x minus 3 over 8x cubed. And yes. All right, so we'll try another one. Now, for dividing, you're going to do the same exact thing. Okay, the dividing is exactly the same process. The only difference in dividing is that you have to flip the second fraction over. Okay, not a big deal. But let's go into something a little bit more difficult, like adding rational expressions. Okay, so we want to do a couple of examples of these, and we're going to see the first kind. Okay, your denominators are a little bit easier than the second group. Okay, but when we add or subtract fractions, you have to remember that the denominators, they have to be the same. Okay, so in this level 1, your denominators are easy to work with, but sometimes they're still not going to be the same. Okay, so we have to find a common denominator. All right, now when you do this, one thing that you can do is you can break these down into, I don't know, the product of prime factors. Okay, now this is only something you only want to do when you have monomial factors. But when I say product of prime factors, I mean like rewrite the 9x as 3 times 3 times x. Okay, rewrite the 9 over 8x as 9 over 2 times 2 times 2 times x. Okay, so once you write it as a product of prime factors, it's a little bit easier to identify what your common denominator is going to be. Because what you want to do is you want to make sure that each fraction has the same exact prime factors in it. 9 over 2 times 2 times 2 times x. Okay, so you look at it, both of them have x's in them. Okay, so that part's good. But we have 2 3's in the first one. We have 3 2's in the second one. The factors that are in your denominators, they have to match exactly before you can add or subtract these. So what I'm going to do is I'm going to make them match. I'm going to force them to match. I do that by just sticking 3 2's down the bottom of this first fraction. And whatever I do to the bottom, I also have to do to the top. So I'll multiply by 3 2's in the bottom, multiply by 3 2's in the top. Go to the second fraction. We've got the 3 2's, but we're missing the 2 3's. So I'm going to multiply by the couple of 3's in the bottom and in the top. Okay, so this should make my common denominator. This first fraction becomes 40 over 72x. The second one is, what's that, 81 over 72x. Okay, then the operation is subtraction, so we just subtract the numerators. The denominators are going to stay 72x. They're not going to change unless it reduces in the end. So 72x, 40 minus 81 in the top is going to take us to, negative 41. Okay, so that appears to be the solution, negative 41 over 72x. We have to make sure it's reduced, which we can type negative 41 over 72 into our calculators and see if it reduces it. I don't think it reduces it. Negative 41 over 72x. Let's try it out. Negative 41 over 72x. And yeah. Oh, great. And you see this worked out here again. And you can go through the steps and they streamline them just a little bit, you know, find the common denominator. But we end up with the same answer. All right. So let's look at one that's a little bit more difficult. Let's go to these level 2 questions and see what these look like. All right, so we started getting into polynomials as our denominators. And let's not do this one. Let's look for one that's a little bit more complicated. So new problem. Okay, something like this. This is good. All right, so we notice we got this trinomial in the denominator of the first fraction, binomial in the denominator of the second one. We still want to take the same initial steps. We want to factor the denominators of both of these fractions. And they're not going to be too bad to factor. The first one, let's see, that's going to factor into, let's see, it's a product sum rule. So x, something that multiplies to give us negative 12 but adds up to a negative 1, about minus 4 plus 3. Okay, second fraction, we just have x plus 3, and that's prime. It's not going to factor. So this is what we have. We have 3 over x plus 4 times x plus 3. We have x over x plus 3. We have to make sure these denominators are exactly the same. They have to have the same factors in them. So they both have an x plus 3, but the second guy, he's missing the factor of x minus 4. So I'm going to multiply x minus 4 in the bottom and in the top of this fraction. And now the denominators, they do match. Okay, we have 3 over x minus 4 times x plus 3, and then we have x times x minus 4 over x plus 3 times x minus 4. Okay, we've got the same factors in both denominators. So now we can perform the operation across the top. We are subtracting, and I do have to distribute the stuff in the top. I don't have to mess with this stuff in the denominators at all, though. Okay, I'm going to write it as 3 minus, okay, when I work this out, I will have to distribute the top, but in the top only. Okay, so I'm going to take x times x is going to give me x squared. X times minus 4, negative 4, gives me minus 4x. And I want to keep those two terms grouped because they're kind of grouped together with this one fraction right now. Then go to the bottom. And I'm just going to write this common denominator once, x minus 4 times x plus 3. Because the denominator is not going to change. Okay, and that's going to be the denominator of our answer. Okay, so since it is subtraction, I'm going to change it to adding the opposite. Flip this to a plus, and change that to a minus, and change that to a plus. Now, let's see how it works out. Combine any like terms, which I don't have any. I have negative x squared plus 4x plus 3 over x minus 4 times x plus 3. And that looks like a good answer. I don't think anything else reduces. Let's try it out. And let's see if we get it right. X squared plus 4x plus 3. And let's see. Yep. And let's see. Negative x squared plus 4x plus 3. Divide that all by x plus 3. Plus 3 times x plus 4. Oh no. So let's see, where did I go wrong? Let's see, x minus 4, x minus 4. I put a plus instead of the minus 4. Well, same thing, except I got it wrong. We can go back and edit it. Let's just say that's minus. We'll forget that I did that. All right, so that is everything for simplifying rational expressions. Try these problems out, see how you do with them, and if you have any questions, have any concerns, just I don't know, just reach out to me through Google Classroom right now, and keep an eye on Google Classroom to see what's coming up next. All right, thank y'all.